Hello, everyone, and welcome to the webcast. My name is Christine Dursey Davis. I'm the Executive Director of the Ohio chapter of the American Planning Association, and I'm your webcast moderator. Today is Friday, July 12th, and we will hear GIS Automation for Planners, Model Builder. For technical help during today's webcast, you can type your questions in the Q&A box, and I'll do my best to answer those. For your questions related to the presentation, again, just type those in that Q&A box, and we'll get to those at the end of the presentation during the Q&A. Today, we are hosted by the APA Technology Division, so thanks for bringing this session to us. And I know we've had several other sessions this year, so be sure to head over to our website so that you can check all of those out. I'll explain that in a moment. Coming up on your screen is a list of our upcoming sessions. We're actually booking out now into November already, if we can believe it. Head over to ohioplanning.org/planningwebcast to register for these and all of our upcoming sessions. Today's session has been approved for 1.5 AICP CM credits. If you are in need of CM credits, just head over to planning.org, log into your My APA account, and from there you can search by today's title or event number, both of which can be found on our website, ohioplanning.org/planningwebcast. If you're on social media, be sure to like us on Facebook. Just type in Planning Webcast and we'll pop up. On Facebook is where I post any important date or time changes and when new sessions are available for you to register for. And head over to YouTube and type in Planning Webcast. And again, we'll pop up along with our well over 500 session recordings. We record all of our sessions and post them up onto our YouTube channel. So they are always available there for you for free. So again, you can find all of our information, logging credits, getting links to our upcoming sessions at ohioplanning.org/planningwebcast. So that's the end of my housekeeping items. Again, real quick, if you have questions, just type them in that Q&A box. We'll get to them at the end. And with that, I'm going to turn it over to David, who's the chair of the technology division, to kind of kick things off for us. David.
Yeah, and I think it would be worth doing some intros. My name is David Wasserman. I'm, as mentioned, I'm chair of the APA Technology Division. Day to day, I am the civic analytics leader at Alta Planning and Design, where I spend a lot of my time trying to think about how we make the best use of data to advance community goals. And I'll pass it off to Lee. Lee, do you want to introduce yourself?
Sure. Hi, everyone. My name is Lee Plass. I'm vice chair of the tech division, supporting David with this this webinar. And I also serve as an adjunct lecturer in GIS over at Georgetown, and I'll be an incoming PhD student at Berkeley this fall. So excited to be sharing some information about the Model Builder platform today.
Awesome. With that, I think I wanted to go through the agenda with everybody. We'll do a quick about on the APA Technology Division for those unfamiliar. I'll talk about the purpose of this presentation, where it came from, go over geoprocessing and how it works within the context of Model Builder, and then some advanced topics and some tool building and how you might use Model Builder to build tools within the GIS platform, and then a demonstration of what that might look like as well. So those are all things that we'll be going over. And one of the things about Model Builder is I always find it to be an interesting program to work with within GIS, and we'll go over more about its context within GIS. But I like this image that's on the screen because I feel like it really captures how weird but also incredible Model Builder can be as a tool for day-to-day work for planners. So with that, I'm going to go on to talk about the division. So for those unfamiliar, the technology division is one of many divisions within APA that focuses on specific interests or disciplines within the practice of planning. If you want to find out more about our division, we have our website on the screen here, tech.planning.org. which will link to a lot of different resources that we have that we are always looking for members to contribute to, including our award-winning urban and regional resources planning resources repo. This connects to a lot of public data sets that might be very useful as inputs to whatever you might learn from this training. And it was also recognized as a Division Council achievement last year, and was also featured on PlanEdison's top websites of 2021, I believe. Beyond that, we have been doing regular contributions to APA's Planning Magazine for different types of technology and data tools that might be useful to planners. You can find out more about that on our site as well. And we invite you to join the division. We have a lot of things in the works this next year. One of them is we'll be working with a product development grant provided by the APA Division Council to develop a planning handbook and Black Mirror card game, planning Black Mirror card game based on an event that we held at MPC this year. So we're very excited about those things. If you want to find out more, you can ask. You can find out more on our website as well as the time comes. So with that, what's the purpose of this presentation? This presentation comes from a combination of, it's built on a training that was given internally to Alta, but also integrates a lot of amazing content and ideas from Lee's lectures that she's given on GIS. And it comes from hearing from our membership that there's a lot of interest in these foundational technologies and kind of getting some quick webinars with tips and tricks and also some background in hard technical skills on tools like Model Builder and what its purpose is. And so we tried to make this presentation approachable for whether or not you were using Model Builder for the first time, have heard of it, or might even be an experienced user where there might be some things that we show you that you didn't know about before. So foundationally, what is automation and replication is something I want to talk about. And one of the areas that is worth understanding is GIS has lots of options in terms of where you can automate workflows. And when you do this, it can make your work easier. Once a process is in place, it can be replicated, you can reproduce that work more easily. It can be faster. Automated workflows can often be faster than desktop execution if you're just running tools one at a time. It's more likely to make your work more accurate. When you build something in Model Builder or Python or develop a more automated workflow, it's easy to verify what you did. You can inspect intermediate outputs, and it becomes easier to QA/QC your work. And they can be modular. Once you build something, you can integrate it into other workflows and make it so that you're building on something that makes a more complex process approachable. And also they can be shareable. The workflows can be shared with others to enable others to do better work. And what I think a key feature of Model Builder that I really like, or an aspect of automation generally, is tools like that can provide a very clear description of a complex process that can be easily visualized or read by somebody. And so there's a lot of different things that you can do with that, such as creating graphics of workflows for memos if you're trying to work through and explain what you did in a process. But there are a lot of benefits to approaching automation in GIS that way. And in terms of how it might look, in terms of different ways that GIS enables you to interact with tools, it ranges from point and click to Python scripts and even Model Builder and places in between. And I will say that the functionality has changed substantially within a lot of these options over time. Model Builder is great for developing good workflows for prototypes, but but even can be used to make modular tools if you know how to edit parameters and do those types of things. But there is a certain point of a lot of projects where, if you want something that you can use over and over again, it helps to know some of the more advanced functionality opened up in GIS as it might relate to Python or ArcGIS notebooks, that can be very useful for that type of workflow automation. And I think one of the things I wanted to highlight is GIS is often what I like to think of as a trunk for a lot of different work that planners might do. When we think about workflows and we're working across disciplines, it can often feel like there's no standardized way to communicate between different tools in a way where you can get a logical result. But often GIS is one of the common denominators. Some type of geospatial file is often one of the common inputs that might be seen across different tools, that can help you keep your workflows kind of consolidated. And one of the things that I like about trying to keep things in Model Builder is, you're keeping everything in the trunk. When you think about workflows, you might, if you're able to keep everything in one software, you're staying the course in terms of what types of tools you're considering, and you're able to keep the workflow all in one place. But sometimes we want to visualize something in a custom tool, like maybe we want to take it in Kepler GL and we branch out, and that makes a leaf in terms of some type of visualization. But ultimately, you want to always think about, when you're doing your work, how does it rejoin the core output I'm trying to create? How do I integrate things back together? And Model Builder is just a really good tool to try and keep things in one place and think about those workflows in that way. So with that, I'm going to pass it off to Lee to talk about geoprocessing in Model Builder.
All right, thanks, David. So just really quickly, we're just going to cover some basic principles of geospatial analysis in Model Builder. It's worth noting again that this is going to be implemented in ArcGIS Pro, but the underlying principles in this part of the presentation can actually be applied to structure any analysis. And there are other free and open source tools like the QGIS Model Designer that you can leverage to achieve similar end results. So with that being said, next slide, please. We're going to go back to basics. So Esri defines Model Builder as a visual programming language for building geoprocessing workflows. What that basically translates into is it's a tool that lets you easily structure complex analysis with pictures. So to understand how to use Model Builder, we're going to, again, go back to basics. Let's start by getting back to the very root of components of a Model Builder workflow, the tools. So these you may already be intimately familiar with, geoprocessing tools on Esri's ArcGIS platforms. And they allow you to apply a particular operation to input data. So at a really high level, tools are pretty easy to understand. They are comprised of three basic components. One, we've got an input or multiple inputs, like a road centerline layer or a layer that contains the locations of mailboxes or local zoning polygons. Two, you got a function, and that function manipulates the input or inputs, and maybe it calculates a buffer around a point, maybe it summarizes data within a census tract or block group, and so on. And then finally, three, you've got an output. And that's often a new layer, a new field, or possibly a table or a text file that contains the results of the function as applied to your inputs. So let's look at a few concrete examples of tools. And these tools are actually going to come up later during our demo. So we're just going to do a quick primer on them now. And those are going to be spatial joins, join field, and calculate fields. So thank you, David. Let's start with spatial join. So pardon the subheaders. I hope that these are going to sort of help you remember the purpose of these tools as we get into the demo, or at least give you a laugh. So the spatial join tool is pretty handy, especially for smaller data sets. So based on the locations of features, the geometry on your map, you can combine data together. And the spatial join tool, it takes two inputs, two required inputs. and that is a layer containing your target features. And those are the feature, that's the layer that's going to receive the data from a second layer, your join features layer. And so in practice, maybe you'd like to add data from census tracts to points within a tract. In that case, your target layer is the points layer, and your join layer is your census tracts layer. And the output is going to be a new file containing the combined data. So as with most tools, you can add additional parameters, and I've listed them here if you're curious. You can also just Google the spatial join tool for ArcGIS Pro, and it'll give you a really detailed rundown. All right. Let's move on to join field. So the join field tool is somewhat similar to the spatial join tool, but instead of relying on the features, again, the geometry to join the data, it instead relies on common attributes, so fields in the table. So for example, let's say you have a layer that contains the geography for your census tracts, and that layer has a GeoID field. Then you could use the join tool to join in the tabular census data with the same GeoID field. And in this case, your inputs will be an input table or a feature class, and a join table or a feature class. So the tool function will read your inputs, and based on a selected common field, it's going to create a new output field feature class, that contains both data from the input table and the join table. And the tool parameters are somewhat similar to the spatial join tool, but it also offers some options on how to deal with duplicate values as well. So for example, if your target field has multiple values that could be matched with the join field, so one-to-many as opposed to one-to-one matching. So what that would do is ordinarily with the one-to-one, it would match the first occurrence of a common observation within the join field as opposed to the one-to-many where it's sort of accounting for multiple occurrences. So when you use this tool, just be really careful to confirm that the field types match. And what that means is a join between a string field and an integer field is not going to run. So make sure that you're joining two string fields or two integer fields. I'm not sure why you do that, but I'm sure there are use cases for that when you apply the tool. All right, so moving on to the last tool here, the calculate field tool. David, can you progress the slide? Thank you. So the calculate field tool, we're gonna tie up our review of some specific tools with this one. So the inputs, the functions, the parameters, let's talk through that. So the calculate field tool allows you to either create or replace values in a layers attribute table based on an expression. So you basically write your own function that will be applied to every row in your table and result in corresponding values in that attribute table. Or just plain, table. So there's a wide range of operations you can apply, and it conveniently lists those operations in the tools interface. So it's a nice open-ended tool that also lets you work with Python code blocks, and it saves you a bit of time and headache with data management if you don't want to open up your potentially large data sets and try to manipulate them in Excel. So that's it for our tool review. Let's try and take it to the next step here. So we've just familiarized ourselves with some of the basic building blocks of a model, our tools, right? And so now the question is, how do we go about structuring all of these like individual tools into a more complex analysis workflow in Model Builder? So let's look at a really simple example and introduce a framework for structuring your analysis. So remember that diagram from earlier with the input, function, output. Okay, the Model Builder interface actually uses a similar visual syntax where the blue circle indicates input layers, the yellow rectangle is the function, or as they call it, operations via your tools oftentimes, and the green circle indicates the output. So that's oftentimes a new layer. So each one of these little components is connected by an arrow, right? And this new diagram describes a single operation in the Model Builder platform, okay? Next slide. But why bother with the model builder platform if you're only going to run a single operation, right? Where's the efficiency there, aside from maybe scheduling a task? So typically, people employ this platform to run and schedule more complex tasks. And for example, they'll create like these chained operations. So let's take a look at an abstract example of what that might look like. So in this diagram, you can see that multiple operations are being run on separate input layers. And the outputs of those input layers and a third input layer are then funneled into a third operation, which results in a third new and final output. And you can see that in that diagram here. But let's walk through something more concrete, step by step. And specifically, we're looking at this example dealing with prioritizing locations for tree replacement in Washington, D.C. So in this example, we're going to build a model with chained operations to produce a shapefile that will help us keep Washington, D.C.'s streets walkable by helping the city prioritize locations to replace dead street trees. We'll start by taking the street tree location dataset hosted on the Open Data DC website, and we're going to apply a new tool, the Select Layer by Attribute tool, to create a new layer that contains only the features that correspond to the locations of dead trees. Next slide. So now we have this dead trees layer. And we want to take that layer and we want to combine it with some additional information that'll help us prioritize the locations where there are dead trees for replacement. And there's this really helpful data set that lives on Esri's Living Atlas called the Urban Heat Island Factors Tract Level Data Set. So we're just going to use that one as a reference. And that can give us more insight into factors like temperatures, median household income, and the like, that is going to help us help the district serve residents in areas most in need. So instead of running a spatial join on the data, we're instead going to run an intersect, which is going to have a similar result, namely a layer that contains both the locations of the dead street trees and a few fields from the Urban Heat Island Index dataset. And step 3, next slide. So then we're going to take the output from the intersect tool, containing the locations of dead street trees and the tract data, so it's all in one place from the UHI dataset, and we're going to pass it through one final tool to calculate an index that is going to help district employees prioritize locations for tree replacement using the Calculate Composite Index tool. And we're simply going to combine the values across each row for the morning temperature field, the afternoon temperature field, the evening temperature field, the median household income field, and the percentage of tree canopy coverage fields. So we're going to bring them all together and scale them from 0 to 1 using the Calculate Composite Index tool to get an index that represents relative need for street tree replacement throughout the district. So next slide. So what does that entire analysis workflow look like in practice? So here's the entire analysis workflow visualized using our analysis diagram template. But let's take a look at what the results look like, and then we're gonna talk a little bit about how to sort of port this over into Model Builder. So next slide, please. So this is the result, the visualization of the resulting feature layer. It includes a screen grab of the map, a legend, and the attribute table. It's a little small, I know, but this is just, to give you a visual of what came of all of this. Next slide. All right, so how do we get from our analysis diagram to Model Builder? Well, we're going to start with the interface in ArcGIS Pro. So to replicate this analysis in ArcGIS Pro in a new project, go to the Analysis tab, then in the ribbon, select Model Builder, and then you can add data and tools by dragging them in from the Contents and Geoprocessing toolbars. You can create connectors between your data and your tools, and maybe iterators as well if you need to, depending on your analysis, by clicking and dragging between each of the components that you've imported. And then next slide, please. What you end up with is a diagram that looks like this. So this is just the previous, a couple of slides previous diagram, just replicated in the Model Builder platform. So That's what it looks like. So it is worth noting, though, that part of the value derived from using Model Builder for this analysis is this is a process that might need to be repeated regularly upon the same or similar data sets. So automating it can help save time. And here, this is the analysis workflow for ArcGIS Pro, as I mentioned before. So there are a few extra elements or components that are visualized here. So let's talk a little bit about that visual syntax that they're employing in the platform really quick. So specifically, you'll see there's this like baby blue count component, and we didn't really talk about that color coding. So let's get to that really quickly here. So vocabulary and components. So when we're dealing with these components in Model Builder, there are three main types, right? Variables, tools, and groups. Variables, they can include our inputs and our outputs, or as they call it, derived data and values. So that could be like static parameters, maybe. And then there are tools, and those tools can be classed into various groups. So thus far, we've been working with basic geoprocessing tools, which are often dragged over directly from the tool catalog window in Pro. But there are other types of tools, including logical tools and iterators. So logical tools, they let you define logical parameters. If something is true, then do something. If it's false, then do something else. Iterators allow you to iterate or perform the same operation on multiple inputs. And finally, groups allow you to zoom out of more complex analysis and deal with groupings of components as larger chunks in your analysis workflow. So you also get various types of connectors based on the characteristics of your components. So if you're adding data sources to a tool, you can expect a solid line connector. If you're defining particular environment settings or preconditions, you'll get a dashed line. And if you've constructed some kind of iterative analysis that takes model outputs and uses them as inputs for iterations, then your feedback connector will appear as a blue dashed line. So we've covered some of the fundamentals of Model Builder, namely how the basic building blocks work in tandem with the larger model workflow, and the types of visual syntax that are in use. So I'm going to hand things off to David now, who's going to get into some of the more advanced topics or some of the more advanced concepts in Model Builder. So take it away, David.
Thank you, Lee. So yeah, as Lee mentioned, there was a great synopsis of kind of how Model Builder works, how it's structured, and how we build models within it. But there are always devils in the details, and that's something I want to talk about a little bit more too. So in terms of things that you can do within Model Builder that can impact the results of your analysis and the types of ways you manage your data, I would say one thing to keep in mind is the distinction between models, tool versus tool environments. Can I see a raise of hands? How many people are familiar with tool environments? Does this sound familiar? All right. Well, if nobody is, okay, there are some thumbs up. If no, but I'll go over the basics. So okay, there come the thumbs up. A lot of people are familiar. That's great. Okay, excellent. For those not entirely familiar, the idea behind environments is they are all the meta settings of all the tools that you might have running at one time. This could include what is the workspace that you're trying to put everything into. If you want to divert data into an intermediate workspace by default, you can have that be set up in a more organized way. You can pick a custom output coordinate system. You can change the processing extent. I think the most important one that comes up in a lot of work as it relates to raster analysis is cell size and masks and those types of things. If you're doing a lot of analysis with raster data, such as a composite index or something like that. And these environments can be set for either tools or globally within the model itself. And the advantage of setting it globally for the model itself is it gives you a lot of control over how certain operations are done. And I think the only complexity with environments is that these are very these are things that are in the background of apparently every geoprocessing tool, or most of them. And it's just, these settings can have a very large impact on the results of the analysis because they're being set all over the processes that you're setting up. So that's a very useful way to control a lot of different things about your analysis. If you want to make very modular analysis models, one thing to keep track of is potentially the use of inline variable substitution. I know this sounds very scary, but it's not that complicated. One of the things that Lee showed in her previous slides was a count, for example, and you can rename any of these variables to have a name that you would like it to have. And what inline variable substitution does is, if you want to, for example, have a workspace be always defined somewhere else, so you can define a variable that says this is a file geodatabase, I want all these outputs to go to. You could put data workspace as the name, and then within a percentage, within a percentage, between two percentage symbols, you would just put data workspace exactly as the variable's named, and it should effectively have both the input and the output use the actual paths that you set up for your analysis. Similarly, in a more complex example, if you wanted to do something with the count of a select by attribute, for example, and make an expression based on it, or create a field based on it, you could do something very similar, either within the expression window or in other areas such as calculate values or fields, where you're able to just change what's referenced and plug that into your calculations as you're doing that type of work. It's a very, very, very powerful way to make sure that your models are robust and not fragile to changes. It's also worth mentioning that there are a lot of meta utilities. We just showed one example of one in the case of calculate value, or collect values, or get field values. These are pretty advanced tools that I know I don't use a lot, but can be very helpful if you need to calculate a value alone that is outside of a calculate field. This is just a very useful way to get at that. It's one example. And they essentially just enable you to better organize the data and values outside of the geoprocessing framework. You know, sometimes we don't need to calculate every single row or that we might be interested in a calculate field. Sometimes we need a single number based on a lot of the things that we're doing within Model Builder, and this is a good way to do that. I think in the same way that people like compute one-off averages or something in an Excel sheet, this is like the equivalent of that, is the way that I would think about some of these model utilities. There are iterators within Model Builder. These can get very complicated and are very have a few limitations worth understanding. But what an iterator is for every single item that you might have. Let's say you have a bunch of feature classes within a file geodatabase or in a folder. You can iterate and apply your model to every single one of those outputs. And this is where things like inline variable substitution becomes very important, because it provides features like the name of the feature class, where you can say, I want the name to be this underscore projected or something like that. And it's just a very powerful way to automate a very complicated process on a lot of different data sets at once. You can do the same thing by iterating over fields, values, files, layers, tables, even timestamps. If you have timestamps set up for a data set, it's a very good way to go over time bins and run an operation. and it's just a very, very, very powerful way to get done a lot of work in Model Builder at once. However, there are a few limitations. You only get one per model typically, and there are ways to get around that if you nest models. But once you start doing that, you can run into some of the other problems, which is that the iterators can be prone to bugs or breaks within complex workflows. And at some point, you just might want to consider using Python. If you are not careful, these iterators are a very easy way to mess up a lot of data at the same time, which could set you back quite a bit if you don't have backups. But it's just something to keep in mind. Other advanced functionality within Model Builder is the ability to create pathways for if-then logic. My general rule of advice is that if you're doing this a lot, you also might want to consider just using Python. You get a lot more control over the types of logic you might be interested in exploring, but this is one of the functionalities within Model Builder that I think has become more stable over time. And so I do think it's worth understanding and knowing about. One thing for good file and data management to keep in mind is the value of the intermediate data functionality within Model Builder. You'll always see this red intermediate X at the top of your Model Builder models. And when it's run, that data is created for each process or operation you have in the model. And it's flagged by default for anything that is in between different steps. So if you run the entire model as a tool, what it will do is delete all the intermediates for you by default. If you run it in Model Builder, it will only delete the intermediate data when that delete intermediate button is clicked. So it's worth understanding that this does do something depending on how you run the model. And when I mean run it as a tool, I mean you set up parameters for the model, and I'll talk about that near the end. And you set what your inputs and outputs are, and it will effectively delete everything that wasn't one of those specified outputs. This is fairly new functionality, but one worth understanding, especially if you have something that needs to be repeated once a week, or if you're trying to generate automated reports based off of GIS workflows. One of the operations that you can do is run scheduled Model Builder models. So you can say how often you want it to be run, when it begins, and it will essentially run on schedule as long as I think it has access to a license. And there are a few applications of this. You could figure out what are the changes in a parcel data set from your property assessor as you're working with those files as part of your planning work. You could update any type of analysis you do based off of live web data on a regular basis, and potentially republish it back to ArcGIS Online if you're trying to keep something up to date. There are a lot of potential applications of this. I think the exports of models are also a very useful thing to understand about the functionality within Model Builder. One of them is the ability to export to Python files, which is a great way to build a more formal Python script from something you sketch in Model Builder. This used to be very unwieldy in ArcMap, but is actually quite good, or a quite good start within ArcGIS Pro. But I think one of my favorites is the ability to export to graphic, where you can export to SVG. And exporting to SVG is just a very useful way to explain and go through a process to somebody who doesn't have access to the software. You don't need to take a bunch of screenshots. You can just export an SVG, edit it in Adobe or Inkscape or some other vector software, or maybe even PowerPoint, and make it very clear what you did and how, and help people see your steps. And I think the other thing that was added in ArcGIS Pro that should be done is everybody should be using automated layouts. I've been given Model Builder models before where it looked like I don't know, a hamster started eating through the mattress or something equivalent. And I just really think if you don't like the way the auto layout button works for you, you can change it. They've added all of these diagram settings so that you can make your models be stacked vertically. They can change the distance between links. They give you a huge amount of control. And it's just a very, very useful piece of functionality that keeps you organized and actually really helps you find mistakes in your models as well, because things might not be connected the way that you think they are otherwise. So this is from experience, some things that I think I wanted to share about hiccups within Model Builder and the types of tools that apply to them. You know, one of the tools that Lee discussed and is worth discussing more is spatial join because of how ubiquitous it is, flexible and useful. And one of the downsides of tools like this is it falls into a camp of tools that I call like bake once tools, where there are certain settings when you initialize a tool. A lot of tools have what is I think they call an initialization process within ArcGIS Pro, where either there's some type of custom script or something that runs and establishes some of the initial settings of the tool the second you connect data to it. Spatial join is one of those tools where what it does is it will effectively establish the field mappings as, you know, input and output feature classes if you've ever worked with this tool. But if you use it within Model Builder, it gets baked once. You know, by that I mean the field maps are set to the data that you have once you set up the workflow. And if that data changes, like the order of fields or the types of fields, there is a chance that the tool won't work exactly as you're expecting because the field maps were baked, so to speak, when you first put in the input and output data. What typically has to happen with tools like this is you actually have to delete the tool, add in a new one, and then reconnect everything and set up the settings the way that you want. This annoyed me so much, I made a different version of the spatial join tool that I can link to people in Q&A if you're curious. But that's just one thing I wanted to call out there. Being careful about tools that edit data is another thing that is worth understanding as well. When you're developing an automated process in Model Builder, when you have certain tools like join field, also a tool that we covered for a reason, that will edit the data as you're working through it. So if you want your Model Builder model to work from start to finish, no matter what, something to think about is when you're working with tools that edit data, consider making a copy of the original data as an intermediate feature and then running the tool that edits the data, partially because then you'll know that your workflow will run over and over again and have consistent results. Good examples of tools where you want to be careful about this type of feature is the snap tool, which edits underlying vertexes within your data set. And really, like once you edit it, whatever result you get from that, that's what you're stuck with. And if you made a mistake and you want to go back, it's very difficult if you didn't make a copy ahead of time and you have to go back and copy in new data. So I really suggest intermediate copies. Join field is the same way. If you join a field, but the fields are already joined because you reran the model, you will run into issues where you get duplicate fields and things don't line up the way that you wanted. You get the underscore ones and all that other stuff that it adds in when that happens. And it's just worth keeping in mind. Iterate once. Again, I really want to push this that once you're using more than one iterator, you are asking for trouble. It's technically possible in the same way a lot of things are technically possible but inadvisable. And also just when complex model builder models start getting built, like you start nesting models, you feel like you're building more or less a house of cards. You know, you'll run into some QA/QC issues that will lead to diminishing returns. And at some point you might want to consider Python or a notebook or some other tool that might help you give more control over a complex workflow. Well, there was a question for someone experienced in Python programming. Are there any advantages to using model builder model over Python? I'm going to answer that one live, actually, because that brings me to this. I think if you're familiar, or Lee, if you want to answer it live, you can, or I can.
Go right ahead.
I think I think one of the advantages is that sometimes it's easier to sketch out a process in Model Builder a little bit more quickly than it is in Python. That's not always the case. I would say if you're familiar with notebooks, notebooks can be very fast and give you a lot of functionality to inspect aspects of the data that you can't inspect in within the ArcGIS Pro Model Builder interface. I also think the ability to inspect intermediate data within the GIS platform itself, there are a few more options for things that you can do. I think good examples of this are something that would be more difficult to do in Python, but it's technically possible. Let's say you got a symbology just right and you want to see how something looks. You can set a model builder like apply symbology a little bit more easily within the map environment a little bit more easily than if you were doing it within a notebook, for example. I guess one of the advantages of Model Builder, in my view, I guess that I'm getting at, is it's more directly connected to the map interface, which can be useful for certain types of iteration or refinement of a process if you're experimenting. Lee, did you want to add anything?
Yeah, just really quickly. Do you want to double down on the benefits of having like a visual to work with? Personally, when I'm trying to design analysis for Python, I end up creating diagrams that look a little bit similar to the model builder diagrams. So I'll create an outline of some kind. Maybe I'll draw similar connectors. I might do it on pen and paper, use draw.io or something. But at the end of the day, I'm still constructing a diagram with modules that look a little bit similar to what you end up with at the end, what you end up with when you use Model Builder. So if the analysis is fairly, if it's not too iterator heavy, or there's not like a, I mean, sometimes there are some restrictions with the data that you're working with for whatever reason. Sometimes it just makes more sense to do it in the Model Builder platform. I wouldn't say that either of the two is like empirically better in all cases. There are instances where it's much more appropriate to be working exclusively in Python. But yeah, again, that visual is really helpful.
Awesome. So I'm going to move on to tool building. Often the only difference between a model builder model and a tool is whether it has its model parameters set and documented. One of the things that's great for model builder is the ability to set up parameters where you can click on any variable or output and label it as a parameter. And the order in which you does this matters, but what this effectively does is enable you to create things that a user running the tool would see in the tool interface should you make it into something that can be run outside of just like the edit session of a model builder model. And this is done pretty easily. You can right click most things. You'll see the option either to make a parameter, create a variable from a parameter of a tool. You can like click on a process and say, I want a parameter from one of the other parameters of the tool. So for example, if you're running a buffer, the linear unit or join distance can be made one. And that's very useful. And beyond that, once you make those things a parameter, it shows up in the geoprocessing interface like it does for a lot of tools that you're familiar with. And it makes it easy for people to use it as a tool when you do that. and it provides a mechanism to build tools that users can inspect and edit more easily than if they were just using Python. Going back to that original question, what are some of the advantages of Model Builder? If you need to build a workflow that needs some advanced automation, but you want to expose some of the functionality that you have to other people, this can be a very useful thing to make it so that if something goes wrong, they can inspect the model in edit mode and see what's going on, and then give you more information about the issues they're running into. The thing that is often ignored is the edit metadata button. Once something is a model, is you right-click a model's. If you right-click any model within a toolbox that you create, you will see this. And I guess we technically never said how do you create a model, but you go inside of a toolbox, you right-click new model, and it will create one. But one of the things you can do is edit metadata for it. And once you do that, it gives you an interface where you can write descriptions that will appear in the tooltips for the tools. So if you've ever seen the eye that appears in the geoprocessing pane, if it has metadata filled out, then that when somebody hovers over it, it will tell people about what that parameter input is and all the information about it. And scripting tools are similar, but have much more control over the parameter options. It's actually kind of amazing how much control they give you. So when you create a new script, you would go to the parameters, you can put the data type, and this is very much the same interface that you would be able to customize if you did this within Model Builder, I think. But where things get a little bit less similar is when you start getting to like execution and validation. Execution, you're telling it, this is the Python script I'm using. Validation is like some of the pre-processing code that you can add to those tools as you're interested in, or post-processing. I have to go check. So actually, one of the tools that I wanted to give as an example of this is one that I wrote is a proportional allocation tool. You know, very commonly we want to know numbers that relate to a geometry. So how many people are within a quarter mile of this bus stop? And while imperfect, one way to do that is assume the area of overlap of your bus stop buffer with census geography and say, you know, it covers 20% of this census tract, give me 20% of that population, covers 40% of this census tract, give me 40% of that population. And this is actually the same toolbox where that spatial join tool is kept, so I'll link that in there. But it gives you a way to effectively identify what is the amount of something or average of something within an area. I'll just keep going through this. So with all that said, that kind of goes over parameters and advanced topics. Now we're going to jump to a demo. And a quick raise of hands, have you ever had a desire to know like what the legal right-of-way is of a street? Often when this is a very transportation planning specific thing, but often we have parcel data sets and we have centerline data. Oh, that's a lot of plus signs. Great. So this is potentially applicable to some people. Often we have a parcel data set or a right-of-way polygon, and we want to know, you know, how much horizontal space is there for reconfiguration for everything from what we might consider to adding a bike lane to a road diet. Where are the bottlenecks if we were to build that infrastructure? Would we need to require more right-of-way? And, you know, ideally in the real world, you would know things like what are the daily ADTs? What is the roadbed space available alongside the legal right-of-way? But this is one tool that kind of gives you a way to evaluate. This is one model builder workflow, I should say, that gives you a way to evaluate that. And it also depends on a toolbox that I've written, I call Study Line Editor. What it does is a lot of different routines for pulling back lines away from intersections, splitting lines, etc. And one of the tools that it has is what I call Spatial biomimicry, I know that's a very bad joke, but basically it has a tool called Generate Whiskers, where what it does is it creates a perpendicular line of a length that you choose to a line that you have. And I'll go over that. So generally, I'm going to go over this demo, and I have not tried to share ArcGIS during one of these webinars before, and this is my first time trying to do it. So if it doesn't work, don't blame me, and we'll just transition to Q&A. But it integrates, a custom Python tool that I've downloaded elsewhere. It integrates multiple model concepts that we've talked about, and it's a very practical application of where Model Builder is useful. So can I see a flurry of plus signs if you see the ArcGIS interface? Oh, thank goodness. Okay. The colors chosen were not chosen for any sense of good cartography, more to just plug John Nelson's Firefly style, if you've ever played with it in ArcGIS Pro. But he would probably look at this map and say, why have you done such a thing? And I recognize that. That's a fair criticism. But moving on from that, generally the way that this workflow works is if we have a bunch of center lines, and I'll turn off all this other stuff, and I'll turn off these intermediates. Let's say I want to find out for these orange lines, what is the width of the legal right-of-way? There could be two different things that a city might have. They might have right-of-way polygons, and sometimes you need to dissolve them because they split them up. Or they might have a parcel data set. And the use case here is a little more complicated, and I'm not going to go into it that deeply. But in either case, if you wanted to kind of know how wide is the space from here to here between these legal boundaries, while it's imperfect, it's not precise, it's not driven by a survey or anything, it could give you a rough sense of how feasible different changes are in different areas, given the extent of the legal right-of-way within, an understandable margin of error. So how the process that this looks like is, first I have this center line, and I'm going to show how I would make this a parameterized tool in a little bit. I have a center line file that I've selected. It's a sample. That's the orange line I just showed you. To start, before I do anything, I will select that I don't want any freeways in the file. That's all I'm doing there. I will add a unique ID that I call street ID. I will set that street ID equal to the object ID. And then I'm going to integrate some custom tools that I brought in. And so one of the things that you can do is, in many cases, you can find tools on GitHub. I hope people can still see the GitHub interface. But when you go find a tool on GitHub, you'll see all this information. Great. Okay. You can hit download zip. You can unzip the file, going back to GIS, and you can add a toolbox to your project from that. And that's what I did here. I searched for this, I unzipped the toolbox, I added it. And the general rule of thumb is the way that tools are designed is you just need the toolbox and the script folder for the tools to run. And the script just has to be in the same relative location. And the easiest way to check a custom tool if it has what it needs is if you go to its properties and you go to execution. If for whatever reason this isn't showing up, you have a problem. But this gives you a sense of what that looks like. But I have a few tools that I'm running here that are custom tools. There's this pull tool. All the pull tool does, and I might just run this model while we talk about it, but I already have the outputs. What this pull tool does is basically pull back lines away from their endpoints. And you typically want this to be done on lines that are planar, meaning that they break at intersections. this can be used for a lot of different applications, but the point of this is I don't want parallel detectors to basically go into this area here, which will bias my right-of-way sampling statistics. I then split the line into 5 segments, equal length, and then I generate these whiskers, and these whiskers, oops, essentially look like this. So you can see there's 5 lines generated. By pulling back the line, there's a little risk of it going into this area and measuring weird things. When you have really weird streets, there's a limit to what you can do, and you can modify and edit these lines as needed. And you can kind of see some of the issues that can appear when you have weird street geometry. But it does give you a sense of what is possible pretty quickly. So moving on from that, I don't know if I've lost people, but once I generate these whiskers, what I do is I'm going to talk about the right-of-way polygons. I'll talk briefly about the parcel polygons, but what I might do is I might dissolve the right-of-way polygons just to make sure that they don't split in the center, which was the case in San Francisco's polygons. And then I will do an intersect with the whiskers. So when I do the intersect with the whiskers, I'll add that to the display. And again, this is one of the advantages of using Model Builder. I can see all the places where the whiskers intersected with the polygons. And yes, there'll be some weirdness sometimes, and you can clean that up using multi-part to single part or something like that. But generally, you can easily see like where there might be issues with the statistics you're getting. Or maybe it's maybe a feature rather than a bug. I like a good example is there is technically more right of way in this area between these 2 spaces, but it might just be a fluke of the geometry. And so you can see like this is where these things, what they look like. This is how they range detect. And you can think about different ways to get rid of some of these excess geometries, but in a lot of the cases, it will work just fine for what you want to do. And this is like the best case scenario. And so what I do is when I have that intersect, I run some summary statistics. I get the mean, median, standard deviation range of the shape length, so I can see what I might need to QA/QC from this operation. I will copy the features with a new name. And again, this is the reason why I'm copying the features is this join field, this edits the data. So I'm joining back to the street ID all these statistics about different statistics of the shape length of these lines in the appropriate projection. And then effectively making sure that that is clear, that when I'm editing this data, it's being edited on a copy rather than the original centerline file that I was working from, or the filtered one. One could say the select does the same job as the copy features, but just as a matter of best practice, this is a good way to do that. In the case of if you're working on parcel data, you might do the reverse. Instead of a intersect, you might do an erase, where you erase anywhere the parcels overlap with the whiskers. And one way to just adjust this workflow is I could, for example, just change the width of the whiskers to something more conservative. And maybe that will get rid of most of the problem. Or I could do some fancy things with multi-part to single part and selections, but I'm not going to go into that right now because I don't think it goes over everything that we're interested in. So I made that edit. I will hit run. Actually, I'll hit validate so it runs through everything. It's a small area. It'll take a minute or two. But it does kind of go through the demo, and I might hit run and come back to this in a little bit, but it does give you a sense of the workflow. If I wanted to make this into a modular tool, this is where my model lives. If I open this up, there are no parameters set. What I would do is think about okay, what are the inputs that I really need for this to work on any data set? And maybe what I would do is get rid of the selection. I would probably keep the street ID, but I would probably decide I need to delete some of these processes. So I might delete the parcel right-of-way and just make a version that only works on right-of-way polygons, that I'd make this a parameter. I would make the output, the final output, copy a parameter, because that's where the name of the final feature class comes from. And then all these intermediate settings might deserve being a parameter, but I just want to show you how that looks if I hit save, just so you can see. When I open this as a tool, I should see 3 parameters. So I will hit run on this while we do Q&A. And you can see that there's no dialog box. If I wanted to make it have metadata, as I mentioned before, I would do this. Boom. Now, if I open this up again, the user will hopefully be slightly better off than they were before. So I will hit run while we look at Q&A and hope that it works.
Okay, folks, if you have questions, go ahead and type them in. It looks like Lee is answering one question now and not seeing anything else. Do you want to keep going? She's been answering questions.
Oh, good. Excellent.
And you, perhaps.
Excellent.
Is there anything else you want to go over?
Nope. That covers everything that
It
we were
does. I
interested.
am getting, please link your spatial join tool.
I can do that. I'll add that.
Okay.
I'll add the tools.
Great.
Yeah.
Yeah. If you could just, if you have any additional questions, feel free to, reach out directly to the division. We have, we're both present on LinkedIn. There's also a Tech Division LinkedIn group that you can join if you are a division member. David, what is the division's email address if they want to maybe follow up on some
APA Tech Division at Gmail, I believe. And I'm going to confirm that.
Yeah, I think that sounds right. So APA Tech Division at gmail.com is another way to reach us. But yeah, if you have any last minute questions, happy to stay on for another extra, maybe 3 to 5 minutes to get those addressed, if that's okay, Christine.
Oh, yeah.
Okay.
So we are recording the session. We'll post it on the YouTube channel, probably get there on Monday. I think David is gonna update some slides, send them to me, and then I'll get them up on our website so you can have a copy of the slide deck. And don't forget to log those CM credits. And I think that's it for my housekeeping items. So folks, and thanks to the technology division for hosting today's session. We appreciate you and all that you do. And thank you. Everyone have a great weekend, and we'll talk next time.
Thank you, everybody.
Thank you.